So we have another one of these absolute maximum moment problems. It's the same beam as before, except we have again another odd vehicle that seems to be backing up onto the structure. So what's the first step that we have to do? Find the resultant force. So my resultant force will be the sum of these things. So it's just 2 kips plus 1.5 kips plus 1 kip. Let's see, that's 4.5 kips. Now I need to find its position. So again, I'll try to help myself out. I'll make a little sketch. So there's my 2 kip, my 1.5, and the trailer. And then I'm going to imagine my resultant force, which is 4.5 kips at some distance x from the lead. I know my other distances are 8 and 4. So again, I'll pick this front point, I'll call it O. So if I sum moments about O and use the real forces, what do I get? I get 1.5 times 8 plus 1 times 12. So 1.5 kips times 8 plus 1 kip times 12 feet. What's that equal to? This is 12 plus 12 is 24. Now, if I sum moments about the same point and consider just the resultant force, what do I get? I get 4.5 kips times x. And again, those two things have to be equal. So what is x equal to? 2 points, really? Oh. 2.67 feet. That's not a very nice dimension. Oh well, it is what it is. Any questions about that? Did you do? No, it's not.
It's not right. 5.33.
5 point. Well, that's not even better, but okay. 5.33. All right, well, keep your calculators handy because this is going to be not fun. Okay, so case 1 is what? Well, about my center line, so I'll just remind you that the center line for this structure would divide it into 2 15-foot segments. So for case 1, we're going to take the front load, which is the 2 kip, and the resultant force, which are separated by a distance x apart, and space them equidistant about the center line. So that would look something like this. So I'd have my 2 kip force and then equidistant back to the 4.5 kip force. And that distance is going to be 5.33 divided by 2. Is that the 2.67? Okay, so that's going to be 2.67. I should have made this a little bigger. I apologize for the small values there. And then we're going to go back to the next force, which is the 1.5 kip. Now I know between these is 8, and you take away 5.33, you're left with 2.67, huh? That's interesting. And then another 4 feet back to the trail force, which is the 1 kip. But remember, the point we're interested in is going to be right here. That's where we're going to find the moment. So again, looking at the reactions, I would have AY on the left and BY on the right. I'm looking for this. So what would be this part of the curve? When I go to make a cut here, do you want to work the left side or the right side? Yeah, I think the left's going to be easy to deal with here. So if I then draw my free body diagram for that left section, I'm still looking at the moment. I would need the reaction at A, which I haven't gotten yet, but I will. And then we'd also know that the length of that segment is going to be, looks like 12.33. Everybody see that? So let's just, now that that's all set, we just need to go through the work. So if I want to find AY, I'll sum moments at B and set it equal to 0. Now when looking at this set, you can see there's even a bigger advantage to just using the resultant force and not all the forces. And remember the word is and not, right? Resultant force or. So let's not use let's use the resultant force. So about B, it would be a positive 4.5 kips. The distance from B to the resultant force is 12.33 feet. And then AY creates negative moment, and the distance from B to AY is 30 feet. So what's AY equal to? 1.85. That sounds reasonable. Anybody else get that? Okay. Yes. So 1.85 kips. So now I can come down here and sum moments at the cut. And what do I get? Well, I assume a positive bending moment. In my sign convention right-hand rule, that's a positive moment. AY is a negative moment times a distance of 12.33 feet. So the moment is basically AY times 12.33 feet. What do you get? 22.8. Say again? 22.8. 22.8. And that would be kip feet. One down, two to go. So let's go to case 2. So I will redraw my system so you can see where the components land. So there's my reaction at BY and AY. And then about the center line, I'm now going to balance the second force with the resultant. Now the distance between those guys was what? 2.67. Divide that by 2, that's 1.33, right? So 1.33 feet to the right would be my 1.5 kip force. And then 4 feet back from that would be my 1 kip force. To the left at 1.33 feet would be the resultant force. And then we know the distance from the resultant force to the front force is 5.33, right? And where are we trying to find the moment? Here. So now when I cut the structure, left or right? Yeah, there's actually no advantage. Because if you look to the right, I've got to consider this force and the reaction. And you look to the left, I have to consider this force and the reaction. So really, at this point, there's not much difference. It does look visually that going right is better because I think you're also, remember, you're looking at the resultant force. But basically, there's really no bad choice here. But you want right? That seems to be the thing of the day, so we'll go right. So we got BY. And there's our positive moment. Now, this is a little bit different than before. We do have a force to consider. the one kip force, and that's 4 feet away. And what's the total length of the structure? Be 15 minus 1.33, which is 13.67. So now we have all the pieces. I'm sorry, I've run out of space down here, but you can see if I can find By, then I'll be able to find the moment. So let's go back here and find By. How do we find By? Yeah, let's sum moments a day. Remember, we're only going to use the resultant force. So about A, the resultant force creates negative moment. So the distance from A to the resultant force is what? What's 15 is the total distance to the center line, minus 1.33 is 13.67 feet. And then I have By creating positive moment, again at 30 feet. So what's By equal to? 2 something? 2.05? Anybody else get that? Yes. Okay, good. So now I can find the moment by summing moments at the cut. So summing moments about the cut using right-hand rule, the moment is negative. The one kip force also creates negative moment. 1 kip times 4 feet. And then By creates positive moment times a moment arm of 13.67 feet. So what's the moment equal to? Say that again? 38.2. That doesn't sound right. Oh, yeah, this is negative. What'd you get? 24.02. Anybody else get that? Yes. Yep. So 24.02, and that will be kip feet. Okay, we've run out of time for class today, but you can see that case 2 right now is the one that's dominating. So what I'll do, even though I'll stop the video here, I'll finish case 3, and when I publish the solution online, it'll include the last case, but the video will stop here. Okay. Any other questions before we go? All right.